So hello and welcome to this video on numeric data. In this video we're going to talk about the types of numeric data, some operators like arithmetic operators and comparison operators, and few operations that we can use to compute values like square root from the math module. So in Python, numeric data is of two types: integers and floats. Integers are numbers that contains no decimal value in them, while floats contain decimal values. For example, let me assign a number 5 to this variable called number. So in order to determine what type of number this is, just have to print type and pass in the variable. So if I save and run it, we get it's an integer class. So it's 5 is an integer type number. If I just do 5.0, it changes into a float. So in order to convert this, let me have 5.1. So this is a float value. So let me try to convert it into an integer value. So integer value of this is 5. This number would be truncated to 5 alone. So if I save and run it, it's still of class int, but just if I type this, if I print this number, it becomes 5. Similarly, I can have an integer number and convert it to a float, and this changes the number with a 0 with a 0.0 in it. So there are many operators that can operate on numbers. Below here I have listed the operators like addition, subtraction, multiplication, true division, floor division, modulo, and exponent. I have a code here which gives an example of all these. So let me just copy and paste it here and comment it. So if I save and run this, I get the output. So a plus b. So 5 plus 2 is 7, 5 minus 2 is 3, and 5 times 2 is 10, and this is the true division, a single slash. It gives a floating representation of the result, like 5 divided by 2 gives 2.5, and a slash slash b, this is float division. It computes the value of 2.5 just like a normal a slash b, and then it rounds down the number to its lower form like 2. It doesn't round up like 3, it just rounds down the number. So that is called floor. Flooring division means it just rounds down. And a modulus b gives the remainder of the division. So 5 divided by 2 gives 1. And a star star b is the exponent form, which gives 5 times 5, which is 25, or 5 to the power of 2, which is 25. So this a modulo b is often used in many situations, like if you divide a number by 2, you can check whether it is an even number or not by checking the remainder. If it is divided by 2, it should leave a remainder of 0, then it is an even number. And likewise, if it has a remainder of 1, then it's an odd number. You also use it for finding if a number is prime number or not, and this is mostly helpful in such cases. So let's talk about incrementing. Suppose I have a number equal to 5, and what if I want to add this to 1, increment it by 1? You can say number equals number plus 1. What this does is gets the number value of 5, and it just adds 5 to it plus 1, which is 6, and this 6 is stored as the number here. So if I print number, you can see it prints 6. But there's an easier way to do this. Right? Python supports this easier way, which is plus equal to. This produces the same code as number equals number plus 1, but it shouldn't have any space with it. So if I save and run it, it prints exactly the same. This also works for other types of operations like minus, slash, and even exponent. So if I want to do this, 5 to the power 2 is 25 is stored in the number. And there are comparison operators like a equal to 5, let me get the old example, b equals 2, and print a less than b, which should print true or false. So 5 is not less than 2, so it prints false. This comparison operators returns either true or false, which is the boolean value. We can check if they are equal by using this equals command. I can give space to be more readable. So if I save this, it prints false because 5 is not equal to 2, true. And if we want to check whether it is not equal, we just have to use an exclamation mark. So Control S, if I run it, prints true. So these are the various types of operators, comparison operators that Python can support. It can also see whether number is greater than or equal to another number, or lesser than or equal to another number. So now let's talk about few functions that can work with numbers. So if we have a number which is negative 10, and if we print the absolute value, which is represented by ABS, and we pass the number, we get the output as 10. So absolute takes any number and converts it into a positive number. So since negative 10 is negative, it converts into positive. It doesn't have any effect on positive numbers, it prints the same. And another good function to take care of is, like if we have a floating value 5.789, and if we print round of number, we get the answer as 6. So round just rounds the number to its nearest value, which is 6 in this case. And we can be more specific if we want to which values we round. And we provide the second argument, which is if you want to round this number by like 2 values, I have to specify 2 here. So it's round to 2 numbers. So since 9 is rounded to this number, it adds 1 here. So it's 5.79. If I want to round it to like one number after the decimal place, it should be 5.8. So now let me talk about advanced calculations with math module. So in order to find a square root of a number, Python provides us a math module in which we can import the method to compute the square root and many other methods. Import math. So let me print the directory of math to see the method it's offering us. Okay, we can see here sqrt, which is square root, and also has factorial and GCD and many other functions which are advanced, like cos inverse, sine inverse, and so on. I mean cos hyperbolic inverse, I guess. Okay, so let me try to print the square root of 5. In order to do this, we have to print math.sqrt of we type in the number 5, 2.23. Yes, so let me clear. So if you add the name of the module and then followed by a dot operator and sqrt, and we supply a number. So if I want to calculate the factorial of like 6, it should give me 720. Okay. And if I want to print a GCD of two numbers, I suppose GCD of 5, 10, it should print 5, and GCD of 5, 8 should be 1. There's no common divisor except 1. So math has another method like ceil and floor. So if we have a number with 5.78, and if we want to convert this into if we want to round up this value, we say ceil, ceil, and we pass the number. So if I save and run this, we get the output as 6. Since rounding up 5.78 gives us 6. And similarly, there is another method called floor, which round downs the number. Just like floor division, it round downs this number as 5. So there's a little detail to be mentioned. If we input any number from the user, the result may not be as expected. So if I have a variable number that gets input from the user, and I have a variable a and perform an addition with it, so if I print a, you can see what happens is if it asks for an input, let me enter 5, and it gives me an error telling that it cannot concatenate string with an int. So what happens is when we receive a number from the input, let me print the type of number. So it says it's a class string. So when we input any number from the user, it is a string. So in order to convert the string to a number, we just have to typecast with int. So now if we save and run this, get the output as 6. Okay, there's another cool trick that might be useful when you are working with larger numbers. Suppose if you want to enter 10 million, and I don't know how many zeros without confusing myself. It's 10 million, but actually there's an easier way to represent it. We just put an underscore between the numbers so that it improves readability to ourselves. So if we print the number, we get the number as is 10 million. You may be tempted to use a comma, but that won't work here.